Okay, so transformations of non-quadratic, I should have said functions, sorry about that. This is the problem from the worksheet, the part 2. That's the graph that it gave. So what I'm going to do, and notice on the worksheet it doesn't have those marked. So if I show you, it doesn't have those marked, the actual points. I did just so that whenever I was transferring it over. So when you're doing non-quadratic, it's always, or anything that's not just like a perfect line or something like that, it's just like pick the key points on a graph. So I picked this point that was down here, this point up here, this point right here, and that point, and then I'm going to transform those. So I'm also going to create the table just because that's what we're going to look at. So this point over here, 1, 2, 3, 4, 5, 6. So it's at -6, 2, -3, 3, -1, 0, and 1, 2, 2. So those are the points that I pulled off of that graph. You needed to find the domain of the original function. So domain for this one, notice domain is talking about x values. So if I look at all these x values right here, they go from -6 to 2. So you can say -6, 2. Or if you wanted to write it as an inequality, you could say -6 is less than or equal to x, which is less than or equal to 2. That means the x values are between those two. And then the range, if you look at these values, or if you look along the graph, you can see it goes 2, 3, 0, 2. The lowest value is 0. Or I'm sorry, oops, I forgot a negative on that. That's what the problem is. So the lowest value is -2, I'm sorry, to the highest value of 3. Notice the highest value is not the last point. That's the highest value. So it actually has to be that number. You could also write it as an inequality as well. So you could say from -2, or -2 is less than or equal to y, which is less than or equal to 3. Okay. So that's the domain and range of the original. Then when you go based on the f parentheses x -2 plus 3, something that I kept noticing when we were working on that worksheet is that people kept putting, just drawing a u or a parabola. Remember that f means take the original function. So you can't forget that it says take the original function. So we need to take all of these points and move them, since it's -2, we need to move them right 2 and up 3. So right 1, 2, and up 1, 2, 3. Then right 1, 2, and up 1, 2, 3. Right 2, 1, 2, and up 3, 1, 2, 3. 1, 2, 1, 2, 3. And then we're going to create the table. So we have x, and then you're going to notice that we put fx -2 plus 3. So we're going to find the new values and list them in the same order. So they need to be in the same exact order. So I did this point first. So 1, 2, 3, 4. So -4 and up 1. Okay, remember this is inside of the parentheses, so it changes the x value, and we have to do the opposite. So it's actually -6 plus 2. -6 plus 2 is negative 4, and then negative 2 plus 3 gives you 1. So you could just take all of them, just add, or you can just write the coordinates. So that one's at negative 1, 1, 2, 3, 4, 5, 6. Or if we take 3 and add 3, it's 6. Okay, this point is at 1, comma 1, 2, 3. 0 plus 3 is 3. Negative 1 plus 2 is 1. 2 plus 2 is 4. 2 plus 3 is 5. We could also count 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so that was part 2. This was the original, this is the transform. Now let's find the domain of the transform. So domain. Sometimes it's easier, some people find it easier to look at the table of values, or you can look at along the axis. So we go from there to there, or from negative 4 to 4. So negative 4, comma 4. Or you could say negative 4 is less than or equal to x less than or equal to 4. Okay. The range of the transformed, notice it goes from 1 to 6, or if you look on the graph, 1 to 6. So 1, comma 6. 1 is less than or equal to y, less than or equal to 6. Okay, so that was part 2 and question 5.